Welcome back. We're ready now to work on the review the product rule and how to do quick products. So let me throw an example problem up here. If we wanted to find the derivative of x sine x, that's going to involve the product rule. So let's recall the product rule. All right. So when we had the product rule, we first of all assigned each one of these factors to a letter. So you take the product of factors. So we have two factors, each of which are a function. So let's call the first factor u and the second factor v. So in this case, u would equal x and v would equal the sine of x. And if you recall, with the product rule, we had to also find u prime, or du dx if you wish, which would be 1, and v prime, which in this case would be the cosine of x. And then the product rule said that the answer would be u prime v plus, let me see if I got that right, plus u v prime. That is correct, yes. And we saw when we did this before, that's just if we wrote this out, if we start with this corner being u prime, if I start here, if I criss and then cross and add those two products together, I'll get the answer. So for this particular case, the answer would be the criss, which would be 1 times the sine of x plus the cross, which would be x times cosine of x. And obviously you simplify that down as sine of x plus x cosine of x, right? So that is our answer. Now, these derivatives are so easy to do that we probably could just do this crisscross in our head, all right? So let me write it down and do it in sort of quick style here, the same problem. So if I simply call that u and this v, I can just write out, if I remember, u prime v plus uv prime. U prime is 1 times sine x, so 1 times sine x, plus u, that would be x, write that down, times v prime, that would be cosine of x. I can forego the whole part of writing out this grid. The grid was very helpful when you didn't know quite how to get to the answer, but you've done this enough that you can probably right away figure out u prime v plus u v prime. So let's just do a couple of these together and make sure that you understand how to do it quickly without writing out the whole grid. So just another one here. If it had been x squared times e to the x, right? We want to figure out what the derivative of that is. We don't really need parentheses around the quantity because they're factors, not terms. So you just want to circle them and call the first one u and the second one v. All right, so u prime, and then I'll just write this over top. We're going to have u prime v. This is what we need to be thinking, plus u v prime. So u prime v is u prime is 2x, v is just e to the x, plus u is x squared, v prime, the derivative of e to the x is still e to the x, so that's our answer. You're probably, if you look it up in the back of the book, going to see something more like 2x plus x squared times e to the x, or e to the x will be factored out. But both answers are equally good depending on the situation. If we're trying to find the zeros based on the derivative, we would want the second version. So factored form, this one is better for finding zeros. I'll say finding where f prime equals 0. But that's not what we're always doing, but often we are. So books will often give this as the answer. Okay, so let's practice with a few more. So this time I'm going to write it down and we'll break it into steps. Okay, so in your notebook, write that down. And step one, circle U and V and maybe lightly label them. Okay, so two factors, U, V. Make my V look more like a V and less like a U. Okay, now complete the algorithm. Let me write it down lightly. U prime V plus U V prime. Fill in the algorithm. Go ahead and do that. That should be 1 times the cosine of x plus x times the sine of x with a negative. So I will change that plus cosine of x to a minus, and I now have the answer. I'm going to leave the 1 off. Cosine x minus x sine x is the answer. Didn't need to write out the grid. Let's do another one. This one is actually a fun one. X times ln of x. This has nice things happening. So go ahead and circle it. Let me put the equal sign. Circle it and write out the template. Okay, fill it in. You should get 1 times ln of x plus x times, remember the derivative of ln x is 1 over x, so that clearly simplifies to ln of x plus 1. So that came out to be an interesting and nice answer. Let's do one more. As you get faster, you don't need to write out the template every time. So let's write the derivative with respect to x of x squared times ln of x. It'll be similar to the last one. But just to show what you're doing, I highly recommend circle the factors. All right, U, V. This time I'm not going to write the template. Go ahead and see if you can finish it. Okay, so U prime would be 2x times V plus U, that's x squared, times V prime, that's 1 over x, and this will simplify to 2x ln of x plus x, which a book might list as x times 2 ln of x plus 1. All right, so either of these last two things, either is a correct answer. If on an assessment you simply had to give your own answer, I would stop right there. But if you're trying to match an answer key, you often have to factor it, or if it says to give it in factored form. So there you go. That's some practice. Let's do some quick combinations now. So yesterday we were doing quick chain rules. Today we did some quick product rules. So let's put a couple of those things together. Let's look at this one. X times the sine of pi x, right? So when you look at this, you can see we have a chain rule with the sine of pi x, but we have a product as well. So what I would do is circle the factors. It's the outer thing is that it's a product. But what is it a product of? It is a product of the sine of pi of x. By the way, the word of is an indicator that you probably have a chain rule going on because you have a composite function. And x sine x really means x times sine x. And so whenever you have a multiplication, you clearly have a product going on. So what we want to do is label these. I'll do this in red. That will be U for the first factor. This will be V for the second factor. And so we can do this pretty quickly in our heads. Well, let me write out the template. U prime V plus U V prime. Each thing can be done fairly quickly in our head, right? So U prime is 1. V we leave alone, so that's the sine of pi x, plus u, we just write the x again. And now, because of the chain rule, when we take the sine of pi x, we'll have an extra factor of, I'll write it this way first, pi times times the cosine of pi x. All right, so we had learned previously we could quickly get the derivative of the sine of pi x by first taking the derivative of pi x times what the derivative of sine would be, and that's what we get. Okay, now this simplifies. Oops. And into just sine of pi x plus, usually we put the pi in front of the x, pi x cosine of pi x. So that's probably the way the answer would be written. All right, let's do a couple more like that. See if you can do these. Let's do x times the cosine of 2x plus 1. So maybe show your work down here. When you're working in your notebook, I'll show my work down there. So remember your steps. Circle the factors. You may also want to circle any inner composites, and then follow the algorithm, u prime v plus uv prime. Okay, so see the factors first, x and cosine of 2x plus 1. There's an inner composite here of 2x plus 1. So eventually you just circle these in your mind, but for now you may want to actually circle them on the page. And then we fill in u prime would be, oh, we want to label those just to keep myself straight. You don't have to, this is all just to help you along the way. We're getting rid of the grid to speed things up, and eventually you won't even write the u's and v's or the circles, you'll just see it. So u prime is 1 times the cosine of 2x plus 1, and then plus u, x. V prime will be the tricky part. The inner derivative of the green part is 2 times, and then we're going to have a sign, a negative sign. I'll put negative in front, negative sine of 2x plus 1. Remember, with derivatives, the derivative of it's tough because we're doing derivatives and antiderivatives at the same time. So the derivative of the cosine is a negative sign. Obviously, we want to clean this up to look more like cosine of 2x plus 1, which you could have done in the first step, leave the 1 out, and then it's going to be a minus. As you get better at this, you may be able to just do it all right in your head right away. Minus 2x sine of 2x plus 1. So there is the answer. Let's keep going. Let me pause. We can look at that for a moment. Pause it if you need to see it. Okay, the next example. This one's going to get a little bit trickier. Okay, so why is this trickier? Well, this is not a product on the outside, it's a product on the inside, right? So the first thing we have is a composite function. So we have the sine of x times e to the x, and then that's a product. X times e to the x is a product. So we have a product inside of the composite, all right? So this one might be a little tricky to try to do all at once, but you could if you want to. I would probably still think about writing this out as f of g. It's the sine of g. Just real quickly might write out that g then is equal to x times e to the x. That's g of x. So df dg, we'll probably still write this out as cosine of g, and dg dx, this is where I use my product rule. Okay, so then I have the product x e to the x, so that's 1 e to the x plus x e to the x. I believe we did that one already. And this will be equal to the cosine of x e to the x. Now, it's a chain rule, so I put those things together, and I can say that my answer is, let's see, we're going to multiply them. So probably I would put the e to the x plus x e to the x first, and then you would put cosine of x e to the x secondly. All right, and you might see the final answer actually might factor those two e to the x's out if you're trying to match it to the back of a book. So this is a good answer, but you may also see the answer where e to the x is factored out. So it might also look like 1 plus x, e to the x times 1 plus x times the cosine of x e to the x. Those are equivalent to each other, and they're both correct. X a little bit better there. So that is good as well. So that would be a fairly tricky one. You might, eventually you'll be able to do ones like that in your head, but for now, you probably still want to write that out. Here's one more where you probably would want to write it out, right? The derivative with respect to x of the sine of 1 over 1 plus x squared. All right. This one is messy because it is we have a composite, so all of this is a function of that, and then inside of that we have actually a quotient. So there's a good chance to review the quotient rule, which is part of the reason I threw this in here. So for the quotient rule, when we have u over v and we're taking the derivative, it's like the product rule, u prime v, but it's minus u v prime, and we have to remember to put that over v squared. All right. Now this one I probably would do as a quick chain, but then sort of take my time on that product rule. So I would have, if I start with the sine, its derivative must be a cosine of everything that was inside. But then, so I don't need to write out the whole grid, but then I need to multiply by this quotient rule, okay, by the derivative of what's inside using the quotient rule. And so here I just need to be careful. U prime is 0. Okay? Times v doesn't matter because it's a 0. U v prime would be 1 times, the derivative of the denominator is 2x. So 1 times, all right, 1 times 2x, all over the denominator squared, 1 plus x squared, quantity squared. So the final answer isn't going to look like this. The algebraic part, the negative 2x in the numerator over 1 plus x squared, the quantity squared, times the cosine of, we put the trigonometric part at the end, cosine of 1 divided by 1 plus x squared. Okay, so that is the answer. That one, I guess we sort of did that in a quick style. Notice I didn't write out any grids, so I was able to quickly go from the sine to the cosine as the derivative, and then I knew by the chain rule I was going to need to multiply by the derivative of what was in the parentheses, and I was able to use, I guess, a quick quotient rule to get that, and then I cleaned it up and got the answer. So I didn't need to write down all of the steps. It becomes a bit tedious to do so often.